Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to be continuing along the book Eloquent JavaScript, talking about Chapter 6, The Secret Life of Objects. And today we're going to talk about the Iterator interface. If you guys remember last time, we talked about symbols and the best time to use symbols or what symbols are exactly used for. If you guys remember, they are a way to use a very unique, an ability to set a very unique property to an object that has a string description or constructor initializer, but it's not a string, it's a symbol. And it's a very unique thing, and no two symbols are the same, even if you name them the same thing. And it just allows you to then create unique properties for your objects that are not enumerable, so you can't loop over them, and you can't loop through your object's properties and get the properties that are of a key symbol. So there's a special way to do that, and we talked about that in the last video. Go check that out. It was very cool. I'd never really used symbols or heard of them, and today much of the same. I've never really heard or used this iterator interface in JavaScript, but you're going to see that it's kind of a powerful way to iterate over a collection of data rather than just looping through it. Now, there's going to be cases where you want to do one over the other. We're going to talk about that. So I'm just going to kick things off and we'll go to the first slide. So what is the iterator interface? Sorry for the delay there. What is the iterator interface? So an object given to a for of loop is expected to be iterable. We kind of talked about this last time too with symbols and how they're not iterable. So iterable basically means you can loop through it. So what the iterator interface is that in an object, you define a method called, or you implement a method called symbol.iterator. And it's interesting, we see that symbol word there again. So this is like a unique property of the object. It's like a unique property of the object that calls a method named symbol.iterator. So when called, this method returns an iterator. So think about like you have an object pies, it's Thanksgiving time. You have an object called pies, you call pies dot symbol dot iterator, right? With the square brackets. I know it's going to look weird, but we're going to see an example on the next slide. This returns an iterator. Now, an iterator is an object that will implement the next method. So when you create your own implementation of this iterator interface, you're going to get to define how the next method is returned. Because this next method is the actual thing that's doing the iterating, or rather, the iterator is the actual thing that's doing the iterating. So you're implementing the interface, but then the iterator is the actual thing that's doing the looping. And then you implement this next method, which is going to return an object with two properties, a value and a done. The done is going to be a true-false variable to say, oh, are we done looping? True, or are we done looping false? True will only show at the very end. Again, we're going to see an example. And then the value is like the actual value generated from the index of the loop you are on. So this is kind of seen like when you have a simple for loop, looping through an array of numbers, 1, 2, 3, 4. Every iteration of the loop is going to be the number, so that would be the value. So let's just see an example of this. And again, this is something that you have to implement. This isn't something that is just attached to objects that you create. You have to specifically state the iterator function and the implementation that you are using. So you have an object here called myIterable, right? And it has some properties in it, naturally. And this could be named whatever you want. Don't get confused on the name there, myIterable. But it's got properties, and just like all objects have. So you have a data property, which is an array. 1, 2, 3, 4. It's kind of what I was just saying a moment ago. And then you have this property of symbol.iterator, which returns a function, which is a function call. And this is going to iterate over your data. So you provide your own implementation here. This is all, again, you are writing this code here for your iterator object and then the logic for the iterator. So when you call this and you iterate through it, calling the next method here, you're going to do some logic. So you're going to check if the index is less than the data.length. If it is, you're going to return a value of the data at that certain index. So this is kind of just like using a for I loop where you iterate and I is the index. You're going to return that as the value, and then done is false. Else, when it finally does match the length of your array, you're going to return done true, and you're not going to return a value because there is no value at the length of your array. Because remember, an array, the last index is the length minus 1. So your length is 4, but your last index is 3. So this is a very explicit way to state your return value of the next method. Because remember what we talked about on the last slide, next method returns an object with 2 properties. Here you're explicitly stating the 2 properties, but you don't necessarily have to do that. You can use a generator function, which is what we're going to talk about a little bit later. But on the right-hand side, you can see now you're using the iterator. So this was kind of confusing to me. So your myIterable object, you're going to be accessing the property, your symbol.iterator property, and you're going to assign it to another variable. Now, I'm sure that you could just call this and say symbol.iterator function call dot next. I'm sure you could do that, but I guess this is maybe a little more cleaner way, and it distinguishes between, it just kind of distinguishes a little bit better, makes it maybe a little more readable when you assign it to a variable, because now this function call is assigned to the variable, and now you can call the next method that you implemented over here on the left-hand side. So when you call next, you can see here that this is just looping through your array of 1, 2, 3, 4. And it's just printing off it's printing it off in the design or in the illustration of an object here. So it's actually going to print an object with, again, the 2 properties, value and done. That's kind of what the MO is of an iterator. Now, at the very end, you see that you reach the end of your array, and it's just going to print done true because you are at the, you are in fact at the end of your array. So this is the implementation of the iterator interface. You define it within an object you create. You define your next method, and you implement the return values in whatever way you want. So here you could return, value. You could add 1 to each index in your array. You can multiply it by 2. You can do other things here, and you can really customize this in any fashion that you want. And that's really like the benefit of iterating through data like this using the iterator. So like I said, what are the benefits? Why can't you just loop over like a list of things like what we normally do? Why can't you just loop over this data 1, 2, 3, 4 And you can, but the one powerful thing about an iterator is that it offers abstraction. So you are able to hide the nitty-gritty details of your iteration from your clients. So you separate the responsibility of accessing elements and actually iterating over the elements. And maybe this is something that is good for your project. You don't want to expose these details. So this is where an iterator would be highly beneficial. It encapsulates the data. So the data structure details become hidden, again, within your iterator, and the client can interact without knowing, again, the nitty-gritty details of the data structure. So you abstract it out. You separate the responsibility of accessing the elements and actually iterating over them. And then it's encapsulated because the details are hidden. And then there's customization because you can implement an iterator in any way you want. It provides a nice way to customize data structure. So I don't want you guys to get confused on these two words, encapsulation and abstraction. I think I kind of confused it here in these 2 bullet points. The details of the loop are hidden. That's kind of encapsulation. Abstraction is like you're abstracting out the function, or you're separating the responsibility from each other. They're abstracted out. So we saw over here, you're accessing on the right-hand side, but you're iterating on the left-hand side. This is what the abstraction means. It's basically, before, like in a regular for loop, you would access and iterate maybe in the same block of code, but here you can do it separately. And that's kind of why I put 2 screenshots there to kind of illustrate that. Or maybe not intentionally, but that's nice that it kind of worked out that way. So let's go to the next slide, because when is a good time to use an iterator? Well, again, we talked about this in the last slide. When a user doesn't need to know the nitty-gritty details of iteration logic, that might be a good time to use an iterator. Maybe if you have large, complex data sets, it might be better to use an iterator because it's just a way to access indexes in your data set in a much cleaner, more readable way, but only if you're using large, complex data sets. Now, if you're using super simple lists like 1, 2, 3, 4, or just like a list of strings, it's not that complicated, it might be better to just loop. A really simple, just for loop, for I loop, for each loop, because then you have the access to the index readily available. And you can do stuff with the index, like you can, I guess we were doing it in the iterator function too, but maybe it's a little more simple to use the index inside of just a regular for loop. And I think maybe the biggest reason is just it's nearly familiar by everybody when you just use a regular for loop. And if it's team convention to just loop this way, hey, maybe just stick to this. But if you have large, complex data sets and you want to implement the iteration in a certain way, well, then go ahead and use an iterator. So that's kind of when the best time to use or not to use an iterator. Now, we saw that when you implement and when you implement the iterator interface within an object that you create, there's an explicit way to return the value of the next method, which again is the object of an object with 2 properties, value and done. There is an implicit way to do that where you don't have to return the explicit object with value and done. There's an implicit way to do that, and it's with a generator function. So this is on the next slide. And this is maybe a little bit, it's going to look a little bit different because we're defining a class here of range, but eventually we're creating an object of range. So you're going to see here that range has a constructor of a start and an end, so a range of numbers. Think about it like that. You're going to give it a starting number and an ending number. And then you're going to implement an iterator interface that basically goes from start to finish. Now you're going to see here that this doesn't have the next method, and this isn't returning an object with the properties of value and done. It's just yielding I. It's just yielding the index, basically. It's just literally yielding the index, or it's returning the index. So now when you come down here, you create a new object, new range object, and then you can for of loop over each number of the range, and this is going to print out, whatever you put in 1 through 5, it's going to print out the numbers 1, 2, 3, 4, 5. But this iterator here is a little bit different, right? It looks a little bit different. It's not, it's not returning an object again with value and done. But you can do that, but this is a very implicit way to do that. So on the next slide, implementing the iterator interface using the generator function. So a generator function is used to automatically yield an iterator implicitly. That yield value, where it says yield I, right here, the yield produces the values in the sequence. So it implicitly returns an iterator with value and done, but a generator function offers just a more concise syntax. So even though you see yield I, it's implicitly returning the iterator with value and done. But you don't need to explicitly define that, but you can. I know I'm throwing maybe a lot of word salad here, but on the last slide, we see an example of this. So same range example, right? Implementing the iterator interface using a generator function. And then here, the value produced by yield becomes the value property in the iterator result. So yield here, essentially think of that as the value property. Now, loop finishes, you have another return down here to exit out of this function. The iterator result, when the sequence is complete, the done property is true, indicating that the iteration is complete. So when you hit this return, think about that as the done property being true. Up here, think about it as the done property being false. So when you create a new range object, again, 1 through 5, we did this on the previous slide, and then you, instead of using a for of loop, which is what we did back here, down here, of my range, which you can totally do, here we're going to call the iterator function, or we're going to assign the iterator function call of my range to this variable called iterator. And now here, this is the classic way to do it that we saw earlier on in the slideshow presentation, where hand side, that's the yield of I, yielding I. And then when you call iterator.next, and it's the final, when you've gone beyond the size of your array, done is going to be equal to true. And this is interesting here. I guess I didn't notice this difference. Size of your array that it was calling, I'll show you guys here. So I guess that might be another big difference with using the generator function. But again, it just provides a way to implicitly define, return your object with the properties of value and done. Hopefully that was clear, guys. Thank you very much for listening to JavaScript. I don't know what topic we got next time, but thank you guys just very much for listening. Hopefully you guys are getting a lot out of these videos, and let me know if you have any. We'll be back next time. Thank you guys so much. My name is Chris. This has been Chee-Tash. Take care, everybody.